Alright, so now that we have finished off with the lettered questions, we can go ahead and actually start answering the questions from part 1. So first question is, what is the amount of carbon in kilograms that is sequestered in the whole plot? So basically what you have to do is add up the carbon from all the trees. So on your table, once you have the carbon content for all the trees, and that's in kilograms, you'll just add all of these values together, and that's going to be the answer. So when you're doing this this answering of questions part, Excel gets pretty messy. So I recommend that you get your questions organized. So I would say question 1 over here, and I would give the answer to it, or maybe just like what it is that the question is asking for. So maybe total carbon in the plot. And then here the answer for it. So you're going to say this is equal to the summation from all of these values. Boom. Okay, so then question 2. Let's see what it's asking us for. So question 2 is, what is the amount of carbon dioxide in kilograms that is sequestered on the whole plot? So now we just add up the values from the carbon dioxide that is sequestered per tree. So now you're going to be adding up this column's values. So add up all of these together. That's going to give you that number. So the total CO2 in the plot. Excellent. Question 3. So question 3 says, what is the average amount of CO2 that is sequestered by each tree on the plot? Okay, so now we start dealing with the average of all of the of each tree on the plot itself. So what you need to do here, let's see, first we're already at average CO2 per tree on the plot. So what you need to do is you need to find the summation for all of these, right? The CO2 this one's sequestered for all the trees, which you already have. It's going to be the answer for question 2. And then you're going to have to find the average for that. So basically, once you have this number, divide it by 17, which is the number of trees that you have on the plot, and that's going to give you your answer for question 3. Question 4. Okay, so question 4 says, what is the average amount of CO2 sequestered by the plot per year per tree? Okay. So the way you do that is you say, let me see, first average CO2 per tree per year in the plot. Okay, so how you do that is you say, we already have a column that says carbon dioxide per year, and then each of these will be the trees, but each of these values is per that specific tree, so you need an average. So what I would do if I were you is I would also sum up all of the values that you obtain for the trees, and then divide that by 17, basically. That will give you the average of the CO2 that is sequestered per tree that is in the plot per year. Alright, question 5. Okay, so to do this, you need to assume that the plot that you create is indicative of every Western USA forest. So that is just obviously not true, but you're just going to assume that that is the way that it is. So if your plot is 0.01 hectares, which it is, on average, how many trees are located on 1 hectare? So remember that basically you have 17 trees in your 0.1 hectare, and there are 100 of your plots in 1 hectare. So if you have 17 trees in 100th of a hectare, how many trees will there be in 1 whole hectare? I'll let you think about that one. That one's fairly straightforward. So I'll say trees in a hectare. Question 6. So Idaho has about 8,700,000 hectares of forest land. How much CO2 is sequestered by the Idaho's forest land? Okay, so here you need to use the values that you obtained in order to calculate that. So let's go ahead and try that out, sort of. Okay, so what we want to find out here is how much carbon dioxide is sequestered in all of Idaho's forest land. So they told us that Idaho's forest lands has 8,700,000 hectares. So first, we know that our plot is only 1/100th of a hectare, so we need to multiply that times 100, right? And then that we need to multiply times the total carbon dioxide that is sequestered on our plot. Okay, so that question, or that answer, that value, sorry, is the answer for question 2. So whatever your answer is for question 2. Does that make sense? If it doesn't, again, review what I just said. So what you want is, if Idaho forest land has 8,700,000 hectares, how much CO2 is sequestered by the Idaho's forest land? So if your CO2, if the sequestered CO2 weight you already calculated in question 2, in theory, that's for your plot. If your plot is 1/100th of a hectare, you should be able to multiply that times 100 to get 1 hectare. And if there are 8,700,000 hectares of forest land in Idaho, then that number you can multiply times 8,700,000 hectares. Okay, so that will be that value. Okay, question 7. So the big burn of 1910 burned about 1,200,000 hectares, which is 3 million acres, in northern Idaho, northeastern Washington, and western Montana. The peak of the firestorm lasted for 2 days, August 20 and 21st of 1910, and killed 87 people. If all the carbon dioxide is released into the atmosphere when trees burn, which again is also not true because not the whole tree burns up, right? Some of it remains. But let's assume that all of the carbon dioxide is released into the atmosphere when the tree burns. How much carbon dioxide was released into the atmosphere during the big burn? And then show your work. So obviously I'm not going to ask you to show your work in the quiz, but it's going to help you a lot if you know what you're doing. So maybe write down what it is that you're doing. So let's go ahead and look at the table and see how we can figure this out. So in truth, the answer for that question, for question 7, is similar to what we did for question 6, except that we are not taking into account all of the hectares for the Idaho forest land, but only the hectares that burned in the big burn of 1910. So we're still going to use our answer for question 2, which was the amount of carbon dioxide that was sequestered in our plot, and we're going to multiply that times 100 to give us 1 hectare, to give us the carbon dioxide sequestered in 1 hectare. And then we're going to multiply that times the amount of hectares that were burned. So if you guys remember, I think it was 1,200,000. And that should be okay for question 8, or question 7, sorry. All right, let's look at question 8. So, in the US, the average car uses 581 gallons, which is equal to 2,199 liters of gasoline a year. There are about 254.4 million cars in the USA. 1 gallon of gas contains 2.4 kilograms of carbon. So based on those numbers that I just gave you, how much carbon in kilograms does the average car use in 1 year? So here, let's show your work. So we need to write down all of these numbers. So let's do that in our table. Okay, so first let's say, I'm going to make it over here just so that we have clarity. So cars in the USA, we're going to say how many gallons per year, and how much carbon, I think it was. Let me double check on that. Yep, how many kilograms of carbon there are per gallon. 214, oh boy, carbon per gallon. Okay, so we know that there are 254.4 million cars in the USA. Let's write that down. 254.4 million cars. We know that it takes, I think it was 581 gallons per car per year. But let's double check. Yep. Okay. And then each gallon contains 2.4 kilograms of carbon. Okay. And then 2.4. Okay. Excellent. So now let's actually get to the question. So the question asked us, how much carbon does the average car use in 1 year? So here we just want one single car, not the whole 254.4 million. Okay, so we just want one car and we want to find out how much carbon it uses. So if the average car uses 581 gallons and each gallon contains 2.4 kilograms of carbon, then we have 581, right, which is the number of gallons that each car uses, times 2.4, which is the number of, or the amount of weight that each carbon contains of, or each gallon contains of carbon. Okay, so that should give you the answer for question 8. All right, so now question 9. How many hectares of trees contain the equivalent amount of carbon, again this is just carbon, not carbon dioxide, that is consumed by an average car in a year? Okay, so now we have to make a comparison of that number that we obtained for 8 and determine how many hectares would take up all that carbon to be used that the cars are really releasing. Okay, so let's try to do that based on the numbers that we have on our table. Okay, oh, also I forgot to write down here what it is that we're doing. So we said amount of carbon per car per year. Cool. So again, on number 9, we want to know what the equivalence is of hectares of trees that are consuming the carbon or are using up the carbon to the amount of carbon that is used up by one car. So which answer that we have already answered contains the total amount of carbon in a hectare? So hopefully you see that none of them have, but we have a close enough approximation. So we know that the first question answers the total carbon in our plot. So, and we know how big our plot is. So we know that our plot is 100th of a hectare. So if we multiply our plot amount of carbon, the amount of carbon in our plot, for the answer to question 1, times 100 to make it the carbon that is sequestered in 1 hectare, we will have some value of carbon, right? And if we compare that compared with the answer that we obtained for question 8, then we are able to determine how much of that hectare or how many hectares take up how much carbon based on the answer for 8. So basically what you would be doing, or the operation would be to say, okay, the answer for question 8 has to be divided by whatever you get on the beginning part that I wrote there. So and that will give you an X number. It could be, but I don't know what it's going to be. But that's going to be basically how you figure out how many hectares can take the same amount of carbon that one car releases each year on average. Okay. Hopefully that makes sense. If it doesn't, again, pause it, make sure that you understand what it is that I'm doing, and it makes more sense to you. Alright, and let's do question 10 really fast. So, question 10 asks us, how many hectares of trees contain the equivalent amount of carbon, not carbon dioxide, that is consumed by the USA cars in 1 year? So now you are looking at all of the cars in the USA, but it's similar to what we just did for question 9 in terms of trying to compare the hectares to the amount of carbon that is released. So if we go to our table, We're going to use the same idea, except that now you're not comparing it to the answer on number 8, but you're comparing it to the answer of number 8 times the amount of, or times the number of cars that there are. So you're going to use the same formula really, except that you're going to multiply the beginning times the amount of cars that there are in the USA.